Welcome to our live training session number 39, part 3. In this video, we're going to learn how to map out our full throttle areas of operation for the low cam. We're going to take a look at doing our fuel tuning using our closed loop tuning method. We're going to take a look at doing our spark tuning utilizing the per cylinder knock control to guide us in how much spark timing we can run. And we're going to learn how to map this out properly off of our wastegate spring. There's going to be a ton of things to cover in this video, so let's jump into our live training session here so we can get started. Welcome back to our live training session here with our turbocharged Honda S2000. In the last video, we mapped out our idle and part throttle areas of driving. So we did our open and closed loop fuel tuning techniques here for idle and part throttle. We also took a look at doing our spark timing optimization, getting our spark timing table built out here at part throttle with and without a chassis dyno. So that all should make sense right now. So we've lined ourselves up in this video to do the full throttle tuning. Now, in the base map creation video, we purposely went into our table from essentially 0 PSI and higher, and we zeroed out our ignition timing. I've done that for a very specific reason so that we can focus on just doing our fuel tuning first, and we don't have to worry about damaging our engine. This is also going to allow us to take a look at our knock data and seeing what's going to look like with really low spark timing to evaluate if we need to change some of the knock control background information such as the gain or the integrator, also setting up our knock floor values. So we jump in here to our knock control, looking at our table. If it exceeds what we program at a particular RPM point for a voltage threshold, if the knock sensor volts go above that, then it'll kick into the knock control. Now we're going to take a look at doing all that in this video. We have armed our knock control in that base map creation video, the first video. We went to the knock control, turned on the knock control and the per cylinder. We can see they're both on. We zeroed out any kind of fuel adjustments the knock control could make. I don't find that to be very useful. We're just using spark timing correction if it sees any kind of knock events. So we're going to look at this, see how it's going to be functioning, seeing how to set it up right, and then using it in our process to do our spark timing tuning with or without a chassis dyno. So it's going to be something very, very useful. Also for a fail-safe implementation, if anything happens, it'll pull spark timing out on just one cylinder. Now, what I didn't mention in that first video is that you have to have direct fire coil and plug style ignition. So if you're an Evo and you have wasted spark, so you have, let's say, 4 coils, but you're sparking 2 of them at the same time, or if you're on a Honda, let's say BD or H series, and you have a distributor still, you cannot use the per cylinder knock. You have to have one spark plug lead or the one spark plug coil fired off and controlled from the AEM per cylinder. So you can't share any of the coil packs in a wasted spark configuration. It has to be direct fire sequential style ignition system. I wanted to mention that. So jumping back into here. So we're ready to fire it up right now and take a look at some things. Now notice our coolant temperature here is 180 degrees. We're actually able to evaluate the post-start enrichment, or when you fire it off, what's going to happen for the first maybe 10 seconds after you, 20 seconds after you fired it off. We can see what the air fuel is going to read. If it starts to read lean, then we're going to have to jump into our post-start table, which is going to be our start extra versus temp and our start extra decay. The start extra versus temp is going to be how much fuel it adds against a certain coolant temperature, and the decay is going to be how long it keeps that the additional fuel added in. So this is going to be a time-based reference. You can see start extra decay here. It's between 0 and 50 seconds. So this is going to be our post-start, and then we'll find it's going to go right then into our table. Our warm-up enrichment is not going to be used here on a warm engine. We can see it's going to be zeroed out from essentially 176 degrees and hotter in coolant temperature, and we're at 180, so we're not going to have to worry about that interfering with anything. So let's go and fire it up real quick. Let's take a look at the post-start, see if we can make some adjustments. Now these ID1000cc injectors typically need to have more fuel added on post-start. We might notice that our wideband runs lean here for a bit of time until the O2 feedback kicks in and starts to correct it. So let's see what's going to happen. It looks like I went to go fire it up there, and it tried to fire, and then it died right away. So that could mean one of two things. One, it could mean that we might need some more initial crank pulse. This is going to be allowing us to have a modifier for our cranking fuel at a particular coolant temperature, or we need to have some more post-start. So thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.